Today we shall derive an expression for equivalent capacitance of two capacitors in parallel. And two capacitors are said to be in parallel if they are connected between two common terminals. And according to the law of parallel combination of capacitors, if capacitors are connected in parallel, the potential difference across each capacitor remains the same, or potential difference across the combination remains the same, but charge distributes, and the total charge on the combination of capacitors is equal to sum of charges on individual capacitors. And the equivalent capacitance of combination of capacitors in parallel is always greater than the greatest value of capacitance connected. So, first consider two capacitors of capacitances C1 and C2. This is C1 and C2 be the capacitances of two capacitors, and these are said to be in parallel if the terminals or the first plates of the capacitors are connected to a common terminal as shown. This is the terminal 1, and second plates are connected to another terminal. This is parallel combination of capacitors, and the capacitors are said to be in parallel if they are connected between two common terminals or two common points, and the combination is connected across a potential difference or across a cell or battery as shown. Let phi be the potential difference. Therefore, potential on positive terminal of the battery or cell is plus phi, and the potential of negative terminal is equal to 0. Therefore, the potential difference is equal to plus phi minus 0 is equal to phi. It is the potential difference across the combination or two terminals. Therefore, this terminal is at positive potential plus phi, and this terminal is at 0 potential. Plus phi potential and 0 potential. Now, what is the potential difference across first capacitor C1? C1 is the capacitance of this first capacitor. What is the potential difference? Plus phi, it is plus phi, it is 0. Then what is the potential difference across this capacitor? That is also equal to phi. Plus phi minus 0, phi. And potential difference across the second capacitor is again plus phi minus 0, phi. Therefore, if the capacitors are connected in parallel, number 1, potential difference remains the same. Potential difference remains the same. And what is about charge? if a cell is connected, let Q be the charge sent by the battery. Therefore, this Q reaches this terminal and the Q charge divides into 2. That is, let Q1 be the charge stored by the first capacitor and Q2 be the charge stored by second capacitor Q2. Therefore, total charge entered at first terminal divides into Q1 and Q2. Q1 is the charge stored by C1 and Q2 be the charge stored by C2. Therefore, number 1, potential difference remains the same and charge divides or charge distributes or charge divides, and total charge Q is equal to Q1 plus Q2. And when capacitors are connected in series, charge remains same on each capacitor, but potential difference divides, that is V equal to V1 plus V2 in case of series combination of capacitors. But in parallel combination, potential difference across each capacitor remains the same, but charge divides, and the total charge entered is equal to sum of charges on each capacitor. Thus, Q equal to Q1 plus Q2. And according to the definition of capacitance of a capacitor, C equal to Q into C equal to Q upon V. And here charge divides, therefore Q1 is equal to, here C equal to Q upon V, this implies Q equal to C into V. V times the capacitance, or it is the product of capacitance of capacitor into potential difference across it. Therefore, Q1 equal to, here C1 is the capacitance and potential difference across C1 is V. There is common potential difference across each capacitor. Therefore, Q1 equal to C1 into V, and Q2 is equal to, capacitance is C2 and potential difference is V. Potential difference remains the same. Therefore, Q2 equal to C2 into V. Therefore, Q equal to total charge on the combination of capacitors, Q equal to Q1 plus Q2. Q1 plus Q2. That is equal to, but Q1 equal to C1V and Q2 equal to C2V. That is Q equal to, consider this as equation 1. Right? Now, if the combination of two capacitors is replaced by a single capacitor, of capacitance Cp. Cp is the equivalent capacitance of two capacitors connected in parallel. If this capacitor is connected across the same potential difference V volt, let V be the potential difference. Phi remains the same. Therefore, what is the potential at this terminal? Plus Phi, and the potential of this terminal is 0. Therefore, potential difference across equivalent capacitor is plus Phi minus 0 equal to Phi, and Cp is its capacitance. And if Q is the charge sent by this battery or cell, then charge stored on this capacitor is plus Q. The same charge is stored here, same charge is stored, but it divides into Q1 and Q2, that is Q1 plus Q2 equal to Q. Here there are two capacitors. If there are three capacitors, it divides into Q1, Q2, Q3, so on. And here there is only one capacitor. Therefore, the total charge Q is stored by the capacitor of capacitance Cp. Therefore, this Q is equal to, we know that C equal to Q upon Phi or Q equal to C into Phi. Here C is the capacitance of the capacitor. Here capacitance of the capacitor is Cp, charge Q, and potential difference Phi. Therefore, the total charge stored by this capacitor is Q equal to capacitance, that is Cp into Phi. Consider this as equation 2. Here total charge divides, and that is equal to C1V plus C2V. And here total charge is stored by a single capacitor of capacitance Cp. Hence, this Q is equal to Cp into Phi. Therefore, from 1 and 2, Cp into Phi is equal to C1 Phi plus C2 Phi. Here Phi is common, therefore Phi in the brackets C1 plus C2. And this common Phi and this Phi get cancelled, remaining Cp is equal to C1 plus C2. This is the expression for equivalent capacitance of two capacitors connected in parallel. And if three capacitors are connected in parallel, then Cp equal to C1 plus C2 plus C3. If n capacitors are connected, then Cp equal to C1 plus C2 plus C3 plus so on plus Cn. And if two capacitors of same capacitances C are connected in parallel, what happens? That means for C1 is equal to C2 is equal to C, two capacitors of the same capacitance, that means C1 equal to C and C2 equal to C, are connected in parallel, then their equivalent capacitance is given by Cp is equal to C plus C is equal to 2C. If they are connected in series, then Cs equal to C by 2. If they are connected in parallel, 2 into C. If n capacitors are connected, then Cp equal to n into C. Number of capacitors into capacitance. Okay? Therefore, if the capacitors are connected in parallel, then their equivalent capacitance is always greater than the greatest value of capacitance connected. Clear? Therefore, for parallel combination of capacitors, the equivalent capacitance is given by Cp equal to C1 plus C2. For this, consider two capacitors of capacitances C1 and C2 connected in parallel as shown in the figure. The potential difference across each capacitor remains the same, but the charge divides and it is equal to Q1 and Q2. Thus total charge Q equal to Q1 plus Q2. And according to the definition of capacitance, C equal to Q upon V, this implies Q equal to CV. Hence, Q1 equal to capacitance divided by capacitance into potential difference. That is Q1 equal to C1V, Q2 equal to C2V. Hence, Q equal to C1V plus C2V. Now, if this combination is replaced by an equivalent capacitor of capacitance Cp across the same potential difference, it stores the same charge. Therefore, Q equal to Cp into V. And from equation 1 and 2, it is clear that this Q is equal to this Q, that is equal to Cpv. Hence, this Q equal to Cpv equal to C1V plus C2V. V is common and get cancelled, and Cp equal to C1 plus C2. Clear? And this is important for 3 marks. That is, obtain an expression for equivalent capacitance of two capacitors in parallel, or obtain an expression for equivalent capacitance of two capacitors connected in series. Now we shall solve problem on parallel combination of capacitors. Example: three capacitors, 2 microfarad, 3 microfarad and 4 microfarad are connected in parallel. Three capacitors, 2 microfarad, 3 microfarad and 4 microfarad are connected in parallel across a cell of voltage 4 volt. Then find number 1, equivalent capacitance. These capacitors are connected in parallel, therefore their equivalent capacitance is Cp equal to how much? Next, charge stored by each capacitor. Charge stored by each capacitor. Number 3, potential difference across each capacitor. Potential difference across each capacitor. Number 4, mm, energy stored by the system number 5 energy stored by 2 microfarad capacitor, and 3 capacitors are connected in parallel here. Therefore, this circuit can be reduced to a single capacitor of equivalent capacitance Cp. Therefore, this circuit is equal to a single capacitor of capacitance Cp. It is connected across the same potential difference 4 volt. Then what is the charge stored by equivalent capacitance? You can calculate. And the equivalent capacitance, number 1 equivalent capacitance, and equivalent capacitance in parallel combination is given by Cp equal to C1 plus C2 plus C3 plus so on up to n capacitors. And here C1 equal to 2 microfarad, C2 equal to 3, C3 equal to 4 microfarad. Therefore, 2 plus 3 plus 4 microfarad is common. That is equal to 2 plus 3, 5, 5 plus 4, 9 microfarad. Therefore, equivalent capacitance of 3 capacitors is equal to 9 microfarad. Cp equal to 9 microfarad. Then what is the charge stored by this system? Number 2. Q equal to C equal to Q by V. Q equal to C into V. Here C equal to Cp and V equal to 4. Therefore, Q equal to charge stored by the system is equal to, that is Q equal to Q1 plus Q2 plus Q3. And for a single capacitor, that is charge stored on this system is equal to Cp into V, and that is equal to Cp equal to 9 microfarad, that is 9 into 10 raised to minus 6 into V is 4 volt, and that is equal to 9 4s are 36 into 10 raised to minus 6, or 10 raised to minus 6 equal to micro coulomb. This is the charge stored by all the capacitors. But this 36 microcoulomb charge is divided into Q1 plus Q2 plus Q3. Therefore, find the individual charges stored by each capacitor. In second, number 1, charge stored by each capacitor. Let Q1 be the charge stored by first capacitor, and Q1 equal to C1 into V, and charge stored by second capacitor is Q2, and Q2 equal to its capacitance is C2 into Phi, and charge stored by third capacitor is Q3 is equal to its capacitance C3 and potential difference Phi. And here C1 equal to 2 microfarad. 2 into 10 raised to minus 6 into Phi is potential difference remains the same. It is 4 voltage. This is plus 4. It is 0. 4 minus 0, 0. Potential difference across each capacitor remains the same if they are connected in parallel. Hence, it is 4. And that is equal to 8 micro coulomb charge is stored by first capacitor, and charge stored by second capacitor is 3 into 4. Voltage remains the same, into 10 raised to minus 6 or micro coulomb. 3 into 4, 12 micro coulomb. And the charge stored by third capacitor of capacitance C3, that is C3 into V, that is equal to 4 into 4 micro coulomb. 4 into 10 raised to minus 6 I have written as micro coulomb, that is equal to 4 into 4 16 micro coulomb. Therefore, this 36 microcoulomb charge on this system is equal to sum of charges on each capacitor. It is 8 plus 12, 20, 20 plus 16, 36. Therefore, total charge on this system is 36 microcoulomb. Clear? Now, what is the potential difference across each capacitor? Number 3. Potential difference. If capacitors are connected in parallel, potential difference remains the same. That is, potential difference across first capacitor is same, second capacitor also same, and third capacitor also same. That is 4 minus 0 is 4 volt. Therefore, potential difference remains same across each capacitor remains same, and Phi equal to 4 volt. Next, energy stored by the system of capacitors, and energy stored by 2 microfarad capacitor. Now, for equivalent capacitance, number 4, energy of system, that is U is equal to half CV square Cp into Phi square, because capacitance is Cp, and for this charge is 36, Phi is 4, Cp is 9 microfarad. Hence, you can use either half Cv square or half Q square by C or half Q into Phi. And we use half Cp into Phi square, that is equal to half Cp equal to 9 microfarad, that is 10 raised to minus 6 into Phi is 4. Phi square equal to 4 into 4. 2 1 the 2, 2 the 4, 2 the 8, 8 into 9, 72 microjoules, or that is equal to 72 into 10 raised to minus 6, or 72 microjoules of energy is stored by all the capacitors or an equivalent capacitance. Then what is the energy stored by 2 microfarad capacitor? Number 5, energy stored by 2 microfarad capacitor. And for suppose this is 2 microfarad capacitor, its capacitance C equal to 2 microfarad. What is the charge on this capacitor? Charge on this capacitor is 8 microcoulomb. That is Q equal to 8 microcoulomb, and potential difference across this capacitor is 4 volt. Now you can use either half CV square or half Q square by C or half Q into V. You can use either of the expression, and here I use energy stored by 2 microfarad capacitor U equal to half CV square. Here C equal to C1, that is equal to 1 by 2 into C is 2 into 10 raised to minus 6 into V is 4 into 4. Here 2 get cancelled, that is equal to 16. 4 into 4, 16 into 10 raised to minus 6 joules, or that is equal to 16 microjoules of energy stored by 2 microfarad capacitor. And another one problem consisting of mixed combination of series and parallel. Equivalent capacitance of a number of capacitors connected in mixed combination, that is some are in series and some are in parallel. Therefore find equivalent capacitance. Equivalent capacitance. And this equivalent capacitance, it is a mixed combination, therefore equivalent capacitance is represented by C. C equal to how much? And to solve such problems, that is find equivalent capacitance between A and B, first connect or assume that there is a potential difference across A and B. Let V be the potential difference. Now charges move from positive terminal of the battery. This is plus, it is plus, and it is confusion. Therefore first go on reducing this circuit. Let the capacitance of first capacitor is 2 microfarad. This is also 2 microfarad. 2 microfarad. 2 microfarad. This is 1 microfarad and 1 microfarad capacitance. To solve this, first see this 2 microcoulomb or farad and 2 microfarad, they are in series or parallel? They are in series. One terminal plate is connected to another. Therefore 2 microfarad and 2 microfarad, they are in series, and therefore For series combination, 1 by CS is equal to 1 by C1 plus 1 by C2. Or for two capacitors, 1 by CS equal to 1 by C1 plus 1 by C2 can be written as CS equal to C1 C2 upon C1 plus C2. Therefore, this can be written as CS is equal to C1 C2 upon C1 plus C2, and that is equal to, here C1 equal to 2, C2 equal to 2. 2 into 2, 4, divided by 2 plus 2, 4. 4 by 4, 1, or 1 microfarad. Or if the capacitances are same, then C1 equal to C, C2 equal to C, then C square upon 2C, that is equal to C by 2. Or you can use CS equal to C by 2. CS equal to, for same capacitances, C by 2. Here C equal to 2 microfarad divided by 2 is equal to 1 microfarad. Hence, combination of these two capacitors is equal to 1 microfarad. Hence, these two capacitors can be replaced by an equivalent capacitance 1 microfarad. Hence, this circuit can be reduced to 1 microfarad. Now, this 1 microfarad and 1 microfarad, they are in parallel, and for parallel combination CP equal to C1 plus C2, 1 plus 1, 2, that is CP equal to C1 plus C2. Since capacitors are same, therefore that is equal to 2C, you can write, or C1 plus C2, and that is equal to 2 microfarad. Therefore, these two equivalent capacitance of these two capacitors is equal to 2 microfarad. Hence, this can be reduced to 2 microfarad. Now, here 2 microfarad and 2 microfarads, again they are in series. Therefore, for series combination, C divided by 2, that is equal to 1 microfarad. Hence, these two capacitors can be reduced to 1 microfarad. 1 microfarad. Now, again this 1 microfarad and 1 microfarad are in parallel. CS equal to 1 microfarad. Number 4, these two are in parallel. Therefore, for parallel combination, C1 plus C2, 1 plus 1, 2 microfarad. Therefore, combining these two, we get a single capacitor of capacitance 2 microfarad. Right? Now, these two are in again series. Right? Therefore, for series combination, C by 2, that is 1 microfarad. And number 4, equivalent capacitance is C divided by 2. This is also C, this is also C. 1 by C1 plus 1 by C2, or C1 C2 divided by C1 plus C2, or C divided by 2, that is equal to 1 microfarad. Hence equivalent capacitance of capacitance, large number of capacitors connected in series and parallel, is equal to 1 microfarad. And such questions will be appear for 2 marks or in CET JEE. Thank you.